Year 3, welcome back to Maths Skills lesson with me, Mr. Horton. Really excited because I've got 3 different activities for you today. So let's switch that maths brain on and let's get ready to work. You might need a pen and piece of paper to make some notes to help you with your maths, and you might need somebody to be sitting near you so when it comes to talking and explanation you can show them what you know and why you know it. Okay? To help you today, we've got some key vocabulary that I would like you to use in those explanations. I'm going to have a go at saying them and you're going to repeat, okay? Part, whole, equal, unequal, hundreds, tens, ones, orgend, orgend, addend, addend, total, sum, odd, even. Great, and we're going to be talking about equal parts as well, unequal parts. In these sessions, I have not worked with orgend and addend with you as of yet, okay? However, in year 3, you have worked with the orgend and the addend many different times when you're doing addition. So simply, orgend is the amount that we start with, and the addend is what we add to that amount to get to our total or sum. So say I was to start with 10, and I was to add 5 to get 15, my orgend is 10, my addend is 5, and my total or sum is 15. So it's great to spot which orgend, which number you are going to work with, the orgend that we're going to start with, the addend that we're adding to it, and that sum at the end there. Let's get started with our activities. As you can see, I've got one activity hidden but one showing. The showing one, I would like you to help me by talking out loud. Then I would like you to work on the one that is hidden by yourself. Okay? You will need to pause the screen to give yourself enough working out time. Let's get started. Let's see what we know so far. We haven't got any of our whole, have we? But we know we've got a part of 631. Naturally, if we say that quite fast, 631, we end up with the whole that we wanted, 631. 600s, 3 tens and 1 1. Then we've got our 30, which can be partitioned into many different ways. 29 and 1 would do, 15 and 15 as a half fact. You could have chosen any different multiple answers there. Okay, just as long as those 2 parts equal the whole. So, your job now is to think about my sentence at the top. So, for example, we've just done in 631. There are 600s, there are 3 tens, and there is 1 1. You need to think about that whilst doing our part whole model to find our whole and to find our missing parts. Pause the screen, give yourself some working out time. And we're back in. Yes, we've got 554. We know we've got 500s, 5 tens, and 4 ones, and 50 can be partitioned into many different ways. Could have done the half fact of 25 and 25, 49 and 1, 20 and 30. Multiple answers to go there. Get your adult to check. Great. Help me out here. Again, we haven't got our whole. We've got some of our parts, but actually, we've got smaller parts that can help us with our missing part. So 300 and 200. We've got 300s. 200s gives us 500s. Now, we've got 60, 508. Reorder how we say that. 568. That helps us find our whole. So in 568, there are 500s. We can see our 500s. We can see our 6 tens. And we can see our 8 ones, can't we? Great work. Your turn to work with this side. Pause the screen, give yourself enough working out time. Off you go. Right, so we've got 90 and 4, 800 and 100. The 800 and the 100 combine to give us 900. Then we've got 994. 900s, 9 tens, 4 ones. Think about your place value when you're placing them back in. Well done. Help me on this one. We've got 834 as our whole. We know we've got 30 and 4, which tells us we don't need to think about this part. However, we're missing the other hundreds. We've currently got 300, we need 800, so what are we missing? We're missing 500. Hopefully our brains are switching on, this activity isn't too tricky, is it? So we've got in 834, how many hundreds are there? There are 800s, there are 3 10s, and there are 4 1s. Fantastic, that's great work. Now can you pause the screen, allow yourself enough time to solve this part whole model here. Off you go. Great, so we can see 10 and 10 gives us 20. So actually here we have 20. Our whole says we need 922 and we've only got 500 here, haven't we? So how many hundreds are we missing? 500, we need 900, we're missing 400, but we're also missing some ones as well, aren't we? We're missing 402. So 500 of the 400 gives us the 902. 902 at the 20 gives us 922. Just the whole that we were missing. Great work. Again, we have a part whole model to work out together, but my red cross in the top corner signifies that there is a mistake in there. We need to spot that mistake and see if we can correct it. Okay, let's go. The whole of 806. We've got a part of 203, 500 and 203. Great. Does 200 and 300 equal 500? 200, 300. Happy with that? So yeah, that equals 500, and that doesn't give us too much over 806. Right, the 3 and the 3, I can see the 6 there, I'm happy with that. But 500, how many more hundreds do we need to get to 800? 300, don't we? But we've got 200 and 200, haven't we? Yeah, we need 300, but we've got 200 and 200, which is 400, which is the difference of 100. So we've got 100 too many. So we either need to change this or this to 103 to get us to our whole of 806. You need to do the same with your part whole model. Okay, yours is incomplete, so you need to complete it and see if that helps you solve the part whole model correctly. If not, spot the error and change it. Pause the screen, give you more time. Lovely, what do we have? Part of 600, part of 50 gives us 650. Right, now we need these 3 parts to get to 707. Will they? Let's see. So 650 at the 40, 60, 70, 80, 90. So that gets us to 690. Add the 20, 690, 700, 710. But add the 7, 717. So actually, what have we got? We've got 10 too many, haven't we? So we either can change the 10s in this column or the 10s in this column, or you might go and change the 10s in both of these. But we needed to reduce by 10, so we can simply do 30 instead of 40 to help us get to 707. Congratulations if you managed to spot that error. It's great. Look at problems, find the error, because everyone makes errors, and let's look at how we can correct them to make ourselves better mathematicians. Now, you have 5 different part whole models to work with. I'm not helping this time, it's up to you. Pause the screen, give yourself enough working out time, and see if you can find the missing parts or missing holes. Off you go. Right, lovely. Over here we've got the whole of 549, we've got 530. What are we missing? We're missing 19, aren't we? We need 10 more to get us to 40 and the 9 to get us to 49. 30 has been partitioned into 10 and yeah, the 2 10s are missing. So we need 20 there. There's your completed part whole model. 650 40. 50 and 40 are like, so we need to get them together. 50 and 40 is 90, so actually that's 690. Then your 40 can be partitioned into many, many different ways. Get your adult to check. I'm just going to put 20 and 20 in there. 470, 50. 70 and 50 are again alike, so we need to get 70, so 7 tens and 5 tens together, which gives us 12 tens, which is the same as 120. We can then add that to 400, 400, 520. Then our 70, we've got the 5 and the 5 there, which gives us 10. So then we've only got 6 tens left, and we can partition them in many different ways. So we could go 25 and 45. The 20 and 40 gives us 6 tens, the 5 and the 5 gives us that 7th 10. So hopefully we're recognising that now. Now we've got this part whole model. 710, 35 and 35. A double factor of 35 is 70. So now 70 and 710. 70, 10 more, 80, 780. Our 710 can be partitioned into many different ways. 710 is a good one to go for. And our final part whole model is looking at 604, 22 and 404. So if we do the 600 and the 400 will give us 1000. The 4 and the 4 will give us an 8. And the 2 will give us that as a 10. So then we've actually got 1010. And you can partition your 22 into many different ways. We could stick with 11 and 11, and there are our two parts to get to that whole of 22 and to ultimately get to that full whole of 1010. Great work with that activity there. We are now onto our second activity. Okay. We are going to be looking at two different strategies we can use to add numbers together. A simple number line, but also the column method that you are probably most familiar with. Okay, but we're going to use our number line to help us with our addition so we can move to a more mental method. Some methods, the number line, we're going to be more suited to that calculation. However, some we would need our column method to be more suited. But we'll try it with both and see. So we'll work together. We're going to use 103 and we're going to add 72. We'll start with 103. You might add the 2 first. You add the 2 and we're going to get to 105. Nice, we've got the 105. Now we can add the 70. So add the 70. We have now got 175. Nice and simple, wasn't it? Add what you know first. Some of you might have gone for 173 to start off with, then add the 2 to 175. That's again completely fine. Now let's look at our column method, see if we get the same result. We had our org end of 103, we've added our add end of 72, see if we get that total sum of 175. So 103, being careful with our place value columns. 72 is actually 7 tens and 2 ones, so nothing in the hundreds there. Where do we start? We start with our ones. 3 ones and 2 ones is 5 ones. 0 tens and 7 tens is 7 tens. 7 at 0, yes, it's still 7. And then 1 at blank is 175. So 2 different strategies there, but we end up with the same result. Okay, so our total, our sum is exactly the same. Again, we are going to do the same thing. Use our number line. Okay, starting with, might start with 372 as our org end. Now I need to add 406. Partition that off into more manageable numbers. Maybe go 406. Great. We might add the 400 first. So 372, 472, 572, 672, 772. So this is adding 100, 200, 300, 400. Some of us might have just added 400 mentally, and again that's completely fine. but now we add the 6. We've got 772, add the 6, 72, add 6, gives us 8, which is 778. So 778 there with the use of our number line. Right, I would like you to use the column method on your own without my support. I'll come in and I'll help afterwards. But think about the positioning of your two numbers, your org end and your add end. Okay, and let's see if our sum total is exactly the same as when we worked it out with the number line. Pause the screen, give yourself some work now, time. Right, we're back in. So we've got the org end of 372 and the add end of 406. Because we know when we add two numbers together, it doesn't matter in which order we do it. We start with our 1s, 2 and 6 gives us 8, 7 and 0 gives us 7 still, and 3 and 4 also gives us 7. So we've got 700s, 7 10s and 8 1s giving us for 778. Great work. Now, we've got a different addition number sentence, our org end being 603, our add end being 67. I would like you to use the number line to help you solve that addition number sentence. Pause the screen, do the number line, I'll then come in and explain it, then we'll give you time to do the column addition. Off you go. Great, so we should hopefully have started with the org end of 603. We're going to partition our 67 into a more manageable 60 and 7. What I like about this calculation is I can see 3 and 7. 3 and 7 are a bond to 10, so I'm going to automatically add that on to get me to 610. A nicer number to work with. Then I'm going to add the 60 on. So I've only got 110, add 6 10s gives us 710, so we get 670 there. So well done if you managed to solve that number sentence using that number line. Now, can you go off and can you solve it with column addition? Think carefully about your place value and where 67 lies in this grid, and then unpause the screen so then we can work it out together. Off you go. Unpause. We are back in, so we've got 603. We'll get my pen first. 603, add the 67. Where do we start with column addition? Our 1s, just in case something happens, we need to exchange over. So we've got 3 and 7 gives us, yes, it gives us 10, doesn't it? And actually in 10 we've got 0 1s, but we have 110. That 110 is going into the 10s column, where it belongs. Now we've got 6 10s and 110 gives us 7 10s. And then we've got 600 with nothing else, leaving us with 670. Again, ending up with the same sum and the same total as the number line. Okay? However, sometimes we need to go to 100 10s and 1s to keep ourselves organised. But other times we can actually just break the number down, think about it in our head. Okay? That's where we become more efficient, where we're starting to think more mentally. Again, pause the screen to allow you to solve this addition calculation using a number line. I'll come back in, then you can pause the screen to solve it with your column method. Think about starting with your org end, adding the add end, which total and sum you get to. Off you go, pause the screen. Right, let's have a little look. We'll start with the org end of 449. What can we add first? We might add 300, then the 70, and then the 4. So 374. Add the 300, so 549, 649, 749. Okay, so there's our hundreds each. Making those 100 jumps. Again, some of you might have been able to just add the 300, which is completely fine. Now, what can we do now? We could add the 70. couldn't we? Or we might decide to add the 4 first. We could add the 4. So if I go add the 4, 749, 750, 751, 752, 753. So we've got 753, haven't we? And then finally we've got the 70 to add on. Okay, we might add that in 2 different chunks. You can partition that off because actually 53, if I add 50, that's going to get me to 803. Because I know 1550 gets us to that 100. It's 803, I only added 5 tens, now I can add 2 tens more comfortably with 823. So get the sum of 823. So with the number line, think carefully about what can we partition into more manageable numbers, because this is a strategy that's helping us work better in our head. And the column method, which is transferable to lots of different calculations. I would like you to spend the time now to pause your screen and to solve it using the column method and see which one was most efficient. Off you go. Right, we're back in. So we've got 449. Oh, and we've got 374. Think carefully about your place value. We start with our ones, 9 and 4. That leaves us with 13. Yeah, which we know is 3 ones and 1 10. So now we haven't got 7 tens and 4 tens, we've actually got 7 tens, 4 tens and 1 10, which does actually give us 12 tens, which 12 tens is actually the same as 120. So we've got our 2 tens there, and our 100 being carried over. So we've got 400, 300 and 100, which actually gives us 800. So again, our total and sum does end up the same. However, some of you might have found the number line more efficient and others might have found the column method more efficient. It depends on which bonds you are comfortable with in your head. So now, you have got 4 different calculations. You get to choose by looking at it which method you would like to use to solve it, to try and be the most efficient mathematician you can. So are you going to choose the number line, or are you going to choose the column addition method to solve these 4? Look at the calculation first before choosing, because you might be able to spot some connections to make yourself more efficient. Off you go, pause on the screen to give you more time. Right, great. So hopefully you've managed to solve those problems and come up with a total or a sum that is very similar to mine. It's not, let's have a little check. So actually, looking at this calculation here, the 12 and the 8, I spotted that as a real great bond of 20, and then the 600 and 100 are not far off each other. So actually I chose to use a number line for that one. The 712, the 283. The numbers, I can't really spot any efficient bonds there. Yes, a number line would work, however, column addition might actually have been most efficient. Because let's see, the 3 and 2 are going to slot together nice and easy. The 8 and 1 is going to slot together nice and easy, and the 2 and 7 are going to slot together nice and easily. However, 599 and 203, I chose the number line with that one, because you can add the 3 quite easily to get you to the 602, and then you can add the 200s, 702, 802. Didn't need to go column because it would lead to lots of carrying over to different columns. And then with 195 and 567, you might choose a number line to do that, because actually 195 is actually really close to 200. Add 200, take 5 off. That's a really efficient way. If you didn't spot that connection, you need to stop, look at the problem a little bit more, think about being efficient with your maths. However, the column method would get you there. However, number line, using this as your log end and this is the add end, would help really well with that one. We're on to our third activity now, which is looking at odd and even numbers. First of all, you're going to help me with this side of the problem. Then I'm going to reveal the grid where you've got to sort some numbers into an odd and even column. Okay? So you're really good with odd and even numbers already. Just tell me what this number is first of all. Pause the screen, give yourself some work now time. That shouldn't have taken long there. So yes, we've got 10, 20, 30, 40, 50, 60, 66 there. Great. Is 66 even or odd? 66 is even because 6 can be shared equally into two whole numbers. So if we think about sharing our 60, we can easily share our 60, 5 and 5, 5 and 5, 5 and 5, 5 and 5, with all our 10s. 10s and 100s share equally, don't they? However, our 1s, that also shares equally with 3 and 3. So 66 is even because 66 can be shared equally into two whole numbers. Great work. You would get 33, I would get 33. Now we know that numbers with 6 in the ones column are even. Can you please sort these numbers into an odd and even column? Thinking about how you know that that is odd or even. Explain them as you go. Pause the screen, give yourself more working out time. Right, we're back in. We know that numbers with 6 in the ones column are even. So 26, 2 10s are shared equally, 6 1s, 3 and 3. 6, the 10 is shared equally, the 6, 3 and 3. So 16 is even. 63, the 60 will be shared equally into 3 10s and 3 10s, but the 3 1s, yes, it's an odd number. 3 is an odd number because 3 can't be shared equally into two whole numbers. 106, 100 shared equally. Think about lots of those 10s consistently being shared equally, and the 6 is 3 and 3. So we know 106 is an even number too. Now finally 64, 60, yes, shares equally because it's in the 10s column, and 4, yes, that does share equally too. That 4 is an even number because we get 2 and 2. However, it wasn't because of the 6 that made this number even. 4 is also an even number. Great work. If you go, so we've done that number already. Let's have a little look at this number here. Write the number down and discuss whether you think it is even or odd. Off you go, pause that screen. Right, the back in. So we've got the number of 57. 3 10s, 2 10s, 5 10s. Is it odd or even? Let's have a little look. Let's share our 10s. Yeah, nice and even. But those 1s, 57, no, it's 4 and 3. So 57 is actually odd because 57 can't be shared equally into two whole numbers. And which part of it couldn't be shared equally? The 50 could, even though 5's an odd number, but the 7 couldn't. So the ones column tells us whether the number is odd or even. So now that you know that, look at these numbers that have 7s in them. Think carefully whether the 7 tells you whether it's odd or even by sorting these numbers at the bottom. Explain as you go, off you go. Pause the screen. Right, we're back in. So thinking about what we know about 7s, 7's in the 1 column. Oh, 7's in the 1 column, 87. 80 is going to share nice and evenly, but the 7 is odd. 7 shares 4 and 3 as whole numbers. It doesn't share evenly. Again, 317. 300s, the 100s will share equally. The 10s will share equally, but the 7 won't share equally. It's 3 and 4. The 7 in this column is actually 100, 700s. 100s share equally, 50 and 50, 50 and 50, 50 and 50. But the 1 doesn't share equally into two whole numbers, does it? No, we would have to go into fractions. So the 1 actually tells us this is odd. It wasn't the 7 that told us that this was odd. Right, we'll go to 478. Again, the 7's 10's column. 400 shared equally, 200, 200. 700 shares equally because all hundreds, 50, 50, 50, 50, 50, 50. And the 8 is 4 in 4. So actually, this is an even number. And our final number we've got is 1071. Well done if you managed to read that. The 70 will share evenly. 10s, 5 and 5, 5 and 5, 5 and 5. They share equally. But the 1 doesn't. Not into a whole number, it doesn't. It would mean we have to go into a fraction or a decimal. You've got another one to be working out. Find the number, explain whether you think it's odd or even, show that through the picture, and then we'll reveal the other side. Pause the screen, give yourself more time. Right, 10, 10, 10, 10. We've got 5 10s and 4 1s, which means we've got 54. 54 is, it's even, isn't it? It's even because 54 can be shared equally into two whole numbers. Again, no matter the 10s, they share an equal. No matter the 100s, they share an equally. But the 1s, that's what tells us whether we can share equally or not. And 4 can be shared equally into 2 and 2. So now, use that knowledge and your knowledge of 4 in the 1s column to help figure out whether these numbers at the bottom are odd or whether they are even. Okay, off you go. Great work. So, 404, 4 is even. Let's get out in the even column. Clear that. Then we've got 341. The actual 4 is 4 10s. So meaning 4 10s, they're even. But the 1 is an odd number. Look at the 1s column. 64, even. 340, 4 10s is always going to be even. And 0, there's nothing to share. So yes, 40 is going to be an equal number. Then we've got 1004. 1000 again, 500 and 500 can be shared equally. No matter the thousands, no matter the tens, no matter the hundreds, they can be shared equally. It's the 1s that sometimes can't. So 4 1s can be shared into 2 and 2. So that means that is an even number. Again, well done for all that explanation. Right, we've got a problem this time. Because I've got a friend, my friend Tommy, said all of these numbers are odd because they have a 7 in them, and 7 is odd. Is he correct? So Tommy thinks 7 is odd, 67 is odd, 107 is odd, and 276 is odd because they've all got a 7 in, and 7 is an odd number. I want you to think about what the number 7 looks like and what the others might look like to help explain whether Tommy is correct or not. Okay, pause the screen, get some explaining done, and see what we get. Off you go. Right. So is Tommy correct? What did you think? No? You didn't think he's correct? Why? Why? So hopefully when we look at Tommy's numbers, 67, 107 and 276, what do we notice? Yeah, 7 is an odd number because the 7's in the 1s. 67 is an odd number. The 60 can be shared fine, but the 7 can't. It's an odd number. 107, the 100 shares fine, but the 7 does not. 7 in the 1s column, 7 in the 1s column, 7 in the 1s column. But this number, 276, where the 7's in the 10s column, we share our 200, it's fine. Share our 70, that's fine. And we share our 6, that's fine, it's equal. So that number has a 7 in it, but it's still even. Because Tommy's knowledge of 7 being odd, even though that's correct, it only has an odd impact when it's in our ones column of our numbers that we have. So we have a 7 in the hundreds, doesn't have an impact. 7 in the tens doesn't have an impact. But 7 in the ones will certainly have an impact on whether that number is odd or even, because it cannot be shared equally into 2 equal parts. Okay, 2 whole equal parts. That whole is really, really important. So we've actually done 3 activities already, so well done, Year 3. Thank you very much for joining me. I hope you found this session helpful. Keep learning and practicing at home. Thank you.